everyone, I am Sir Alfe and today we will be knowing something about ANOVA. What is ANOVA? ANOVA is also called analysis of variance. It is used to compare the means of two or more groups of independent samples. It is also called F-tests. Why do we use ANOVA? It is being used to find out the difference between and among the columns and the rows of two or more independent groups. It is also being used in looking at the interaction effect between the variables being analyzed. This is also more efficient than other tests of difference. There are two kinds of ANOVA, the one-way ANOVA and the two-way ANOVA. The one-way ANOVA is used when there is only one variable, while the two-way ANOVA is used when there is two variables involved, the column and the row variable. Today we will be focusing on the two-way ANOVA. What is two-way ANOVA? It involves, as I mentioned a while ago, two variables, the column and the row variables. It is also used to find out if there is an interaction effect between two variables. 30 mathematics students were randomly assigned to one of the three instructors and to one of the two methods of teaching. Achievement was measured on a 50-item test administered at the end of the term. This is the example of the data being mentioned in the example. In the columns, we have the teacher factor, or the teachers A, B, and C, and for the rows, we have the method of teaching 1 and the method of teaching 2. From the given example, we can create the following problems. Number 1, is there a significant difference in the performance of students under the three different teachers? Number 2, is there a significant difference in the performance of students under the two different methods of teaching? And number 3, is there an interaction effect between teacher and the method teaching factors? Now, we can formulate three hypotheses. First is we will have the null hypothesis. There is no significant difference in the performance of the three groups of students under the three different teachers. And our alternative hypothesis would be there is a significant difference in the performance of the three groups of students under the three different teachers. The next null hypothesis would be there is no significant difference in the performance of the three groups of students under the two different methods of teaching. And its alternative would be there is a significant difference in the performance of the three groups of students under the two different methods of teaching. The last null hypothesis would be interaction effects are not present, and its alternative hypothesis would be interaction effects are present. This time, how are we going to interpret the data? If the F computed value is greater than the F critical value, this confirms the null hypothesis. On the other hand, if the p-value is less than or equal to 0.05, reject the null hypothesis and accept the alternative hypothesis. And if the p-value is greater than the 0.05, then accept the null hypothesis. This time, we will be plotting our data into a Microsoft Excel. We will allow the Microsoft Excel to compute the ANOVA result of our data. From your data, you will have to click Data in your command button and then click Data Analysis. Then a window will come out with the ANOVA two-factor with replication from the options, and then you have to click OK. A new command will pop out and it will require you to input your range, and then you can just have to click the whole table of your data and then input the rows per sample. We have here 5 rows in every sample, and of course ensure that your alpha is 0.05, and then for the output options, any part of the Excel, and then the summary of the results will come out. You have here ANOVA two-factor with replication, and the summary will have the three columns A, B, and C, which represents the three teachers, and then the methods of teaching 1. Then you will have the counts and the sum also counts. We have 5 cases, 5 for A, 5 for B, and 5 for C, and the sum in each groups. Then you'll have the average and the variance also. For the method of teaching 2, the same. You'll have count of 5 in each group, the sum Also in each group, the average and the variance. This is now the interpretation of ANOVA. We have here in the first column the source of variation, the sample, the columns, and the interaction of all the variables, followed by the second column, which is the sum of squares, and then the degree of freedom, mean squares, the f value, the p value, and the f critical value. For the sample, take note that our p value here is greater than 0.05, which means that we will have to accept the null hypothesis. And our f value is less than the f critical value, then therefore we will also have to accept or confirm the null hypothesis. And for that, which means that there is no significant difference in the performance of the three groups of students under the three different teachers. Then on the second result, we have the columns and the p-value is also greater than 0.05, while the f value is greater than the f critical value. This means that we have to disconfirm the null hypothesis. While for the interaction, though the p-value is greater than the 0.005, its f value is also greater than f critical, which means that we will have to reject or disconfirm the null hypothesis.